All right, previous video, we reviewed this right here, being able to find the atomic number, the atomic mass, the name of the element, and the symbol. And remember, atomic number is the number of protons the atom would have. The atomic mass would be the protons plus the neutrons. And remember that this is a decimal because it's averaged between the most common types of those isotopes, okay? So now we're going to start getting into bonding. In order to understand how atoms bond, we have this word called an ion. We focused on three types of bonds last year in physical science. Although we spent most time on two: ionic bonds, covalent bonds, and then the third one we mentioned a little bit, hydrogen bonds. Okay, but we got to know this other vocabulary before we get there. So an ion is an atom that has gained or lost an electron, and when it loses an electron, it causes a charge or causes that atom to be charged. Okay, so there's two types. First one's called an anion. An anion is a negative ion. A negative ion is negative because it has more electrons than it does protons. So if you look at this one right here, for example, sorry about that. So right here I have 1, 2, 3, 4, 5 electrons and 1, 2, 3, 4 protons. Since I have more electrons, which are negative, than I do protons, this is a negatively charged anion. It's picked up an electron. Okay. Great example of that, chlorine. Chlorine has 7 valence electrons. Now, what is a valence electron? A valence electron is the electrons in the outer shell. And in physical science, you learn that atoms want to have 8 valence electrons to become stable. All right. So what they'll do is they'll go pick one up or they'll get rid of one to become stable and fill that outer shell. So since chlorine has 7 valence electrons, well, guess what? It's just going to pick one up to fill its outer shell. When it picks up that one electron to get a full valence shell with 8 valence electrons, and now as an anion with a charge of -1. The opposite of that is a cation. Cation is a positive ion. So if I'm looking at this guy right here, I have 1, 2, 3 electrons that have a charge of -1, and then 1, 2, 3, 4 protons that have a charge of +1. So since I have more protons than I do electrons, now I'm going to have a +1 charge on this atom. Sodium is a great example. Sodium has 1 valence electron. So that one little loner out there, it's a lot easier for sodium to get rid of 1 electron than it is to pick up 7 more to get that 8 electrons. Okay, so it's going to lose that guy, and then it's going to end up with a charge of +1 because now it's going to have 1 more proton than it does electrons. So this leads us to bonding. Okay, atoms are going to form compounds to become stable. So remember, we want to have 8 valence electrons. So they're going to go find basically a partner. Atoms are going to find a buddy in order to pair up with to give them those full valence shells or 8 valence electrons. Okay, so 2 types of bonds that we'll discuss. Well, really 3, but let's focus now for just 2. First one's a covalent bond. Covalent bond doesn't involve atoms gaining or losing electrons. It basically just is when atoms will allow their shells to overlap and they'll share electrons. Okay, so there's no getting rid of or dropping or picking up extra electrons. They're just going to share. Basically, they got a buddy. And when they do that, their valence shells are overlapping. This formed between 2 nonmetals. Remember, nonmetals in their location on the periodic table, on the far right side of the periodic table. And they've got to form molecules specifically for us. We're going to see how it forms a water molecule. Then we have an ionic bond. An ionic bond is when we do have a transfer of electrons. Okay, when one atom loses an electron to become positive, and then one atom gains an electron to become negative. Now I have 2 things that are oppositely charged, a cation and an anion. Just like magnets, when magnets I put the positive end of one magnet to the negative end of another magnet, they stick together. That's the same thing with these things. or with these atoms, these cations and anions, they now attract to each other because of their opposite charges. These form between a metal and a non-metal. Remember, that's like the left side of the periodic table bonding with the right side of the periodic table. A great example of that is NaCl, which is table salt. So I just talked to you a moment ago about how sodium and chlorine form different anions and cations. Well, when they do those, they stick together. And up here it says when bonds are formed, it changes the properties of the element within the compound. Here's a great example. Sodium, or Na, is a metal, silvery metal. Doesn't sound like something I want to eat. Chlorine is a gas. It's a poisonous gas. It'll kill you. But when I put these two things together, anybody know what NaCl is? That's table salt. Okay. When they bond, the properties of the atoms change because of the reaction that they've gone through, and that's going to give us our table salt. Or, like for example, hydrogen and oxygen, when they bond together, that's two gases. Well, wait a second, they form water. Okay, so the properties have changed. Our third type is a hydrogen bond. This is a weaker bond. This is something we're going to talk more about when we get to water. All right, so here we go. I have covalent bonding. When atoms are sharing electrons, see how their valence shells overlap. So these are two fluorine atoms. It gives me a fluoride molecule. And then water, look here. This hydrogen is going to come real close to here. This hydrogen is going to come real close to here. And they share those outer valence electrons to become a water molecule. Polar covalent bonding, that's something I'm going to talk more about in a later video, so I'm going to hold off on that for just a second. And then ionic bonding. Remember, sodium will easily lose an electron. Chlorine will easily pick up that electron. When that occurs, I have a positive sodium bonding to a negative chlorine. That's going to give me my ionic bond or ionic compound. Now this video, I'm not going to play it for you on my video, but watch this video. This is so important. It just gives you a better explanation of what I just said there. Happy watching.